Welcome everyone. Through this video, I am going to discuss how to find limit using L'Hospital rule. Using L'Hospital rule. So, what is L'Hospital rule? Limit x tends to a fx equals to limit x tends to a gx equals to 0. The limit x tends to a fx by gx, if it is of the form 0 by 0 form, this is equal to limit x tends to a f dash x by g dash x, provided g dash k not equals to 0. If it is 0, then it is undefined. Now, this process may be repeated. If it is again 0 by 0 form, then we take f double dash x by g double dash x. And the above rule is also valid if it is of the form infinity by infinity. So 0 by 0 and infinity by infinity. So if we use L'Hospital rule, then problems. So, to find the limit by using L'Hospital rule, it will take minimum time. So, let us consider an example. So, problem number 1. Limit x tends to 1. X plus x square plus x cube dot dot x to the power n minus n by x minus n. Now you know, without using L'Hospital rule, we take n as x minus 1, x square minus 1, x cube minus 1, x to the power n minus 1 by x minus 1. Then, writing it as a sum of n limit, we can evaluate it using standard formula. But using L'Hospital rule, look, it will be very simple. So 1, 1, 1, 1. So n times. So this is n minus n. So this is 0 by 0 form. So we can use L'Hospital rule. If denominator is first degree or second degree, then it will be simple to use L'Hospital rule. But it is of the form fourth degree. Then it is you have to differentiate 4 times. So write limit x tends to 1. So 1 plus 2x plus 3x square n x to the power n. So derivative of n is 0. So this is 1. Now if we put x equals to 1 directly, we get 1, 2, 3 dot dot n. It is defined and value is n into n plus 1 by 2. So it will take least time if we use L'Hospital rule. Now for problem number 2. Problem number 2. So 2fx, 3f of 2x, f4x by x square. Now if we put this is 2f0, f0, 3f0 minus 3f0, 0 by 0 form. 0 by 0 form. So we use here L'Hospital rule. So limit x tends to 0. So it is given that fx is differentiable. So this is 2fx, 2f dash x into 1. So 6f dash 2x, 3fx into 2, and this is 4f dash 4x by 2x, x square derivative 2x. So if we put x equals to 0, 2f dash 0, 4f, 6f dash 0 minus 6f dash 0, it is again of the form 0 by 0. So we can differentiate it again by L'Hospital rule. So limit x tends to 0. So this is 2. This is 2f double dash x. 12 f double dash 2x. 16 f double dash 4x. So 4 into 4. So if we put x equals to 0, this is 2. So 2 f double dash 0. 12 f double dash 0. 16 f double dash 0. So finally 18 minus 12. 18 minus 12. So 6 f double dash 0 by 2. So 3 f double dash 0. So f double dash 0 is k. So answer is 3k. So using Hale Hospital rule 2 times. So this type of problem, if nature of function is not given, we always use Hale Hospital rule for competitive exam. So answer is 3k. Now problem number 3. Exactly same problem. So limit x tends to a, gx into fx, ga into fx by x minus a. So gafa minus gafa. This is of the form 0 by 0. So using Hale Hospital rule, limit x tends to a. So fa is constant, fa into g dash x minus ga into f dash x by 1. Now put x equals to a. So fa into g dash a minus ga into f dash a. Now put the given value. So what is fa? Fa is 2 and g dash a is 2. 2 into 2. ga is 1. F dash a is 1. So answer is 3. So form of fx is not known. So use Hale Hospital rule. If it satisfies the form 0 by 0 or infinity by infinity. So look it again. So fa into g dash a minus ga into f dash a. So ga is minus 1. So this is minus 1 and f dash a is 1. So this will be plus. So answer is 5. Sorry. So ga, this is minus 1. So answer will be 5. Now we consider these two problems. Limit x tends to 1 minus cos x by x to the power 4. Cos of sin x minus cos x by x to the power 4. Now if we put x equals to 0, cos 0 is 1. So this is 1 minus 1, 0, cos 0 is 1. So this is 0 by 0 form. And it is also of the form 0 by 0. Now look, if we use Hale Hospital rule, this is 0 by 0 form. Now it is x to the power 4. So you have to differentiate denominator 4 times. But look, numerator, if we differentiate it, then cos of the sine of 1 minus cos x, then derivative of 1 minus cos x. Argument is not first degree algebraic. So then from second step you have to differentiate the numerator by product rule. Then again product rule, it will be lengthy. So similar case for problem number 2. In this case we avoid Hale Hospital rule. We use ordinary method of finding limit. So suppose problem number 2. this is limit x tends to 0. So cos c minus cos d. So sin c plus d by 2. Argument sin x plus x by this. Sin x minus sin x by 2 by x to the power 4. Now as x tends to 0, this argument tends to 0 and this argument tends to 0. So we write it in this form. Limit x tends to 0. Sin x plus x by 2. So balance it by the argument. Since argument tends to 0. Similarly for the second one, x minus sin x by 2 divided by sin x minus sin x by 2 divided by this argument. And this is limit x tends to 0, x to the power 4, x minus sin x, x plus sin x. By 4. So sin x plus x by 2. So this is balanced, x minus this. So it is balanced. Now first limit is 1, second limit is 1. Second limit is also 1. And third one is limit x tends to 0, the balancing factor. 4x to the power x. X minus sin x, and this is x plus sin x. So 1 by 4 outside, limit x tends to 0. So x minus sin x by x square, limit x tends to 0, x plus sin x by x square. Now it is 0 by 0 form. So we can differentiate it. So by L'Hospital rule, because here argument is simple. So this is 1 minus cos x by 2x. Second one is 1 plus cos x by 2x. Derivative of sin x, so 1 plus cos x by 2x. Now look, limit x tends to 0, 1 minus cos x by x square into 1 by 4 into limit x tends to 0, 1 plus cos x. This is half. You know this is half. So half into 1 by 4 and this is 1 plus cos 0. So answer is 1 by 8. Answer is 1 by 8. So you first look the problem. It is fourth order. Argument is not linear. So if you differentiate first time, so derivative of argument is again a function. So second order derivative lengthy, third order, fourth order. In this case, we do not use L'Hospital rule directly. Look, this is 1, this is 1. But here argument is only x minus sin x. First, so look, linear. So we use L'Hospital rule. Now we know 1 minus cos x by x square is half. And so that is why this x is balanced here. So answer is 1 by 8. Now we consider two more problems, 11 and 3. Problem number 11. Most important problem of JEE Main and Wbjee also. Let f(R2R) be a differential function such that f2 equals to 2. Limit x tends to this equals to what? So limit problem is limit x tends to 2 2 to fx 4t cube by x minus 2 dt. Now integration depends on t. So x minus 2 is independent of 2. So 1 by x minus 2 unchanged. Now 4t cube, integration is t to the power 4. This is fx, this is 2. Now limit x tends to 2. Fx to the power 4 minus 2 to the power 4 by x minus 2. Now if we put x equals to 2, so this is f2. f2, 2 to the power, f2 is 2, 2 to the power 4 minus 2 to the power 4. So this is 0 by 0. Listen again, f2 is 2. So 2 to the power 4 minus 2 to the power 4. This is 0, 0 by 0 form. So we use here L'Hospital rule. This argument is x minus 2. Denominator, is x minus 2. So derivative is 1 and argument is x. So 4 fx to the power 3 into f dash x. Now put x equals to 2. So 4 into f2 to the power 3 into f dash 2. Now f2 is 2. f2 is 2. So 2 cube, this is 8. So 32 f dash 2. Answer is 32 f dash 2. So look, if we use L'Hospital rule, so it will take very few minutes. Minimum time. It will take minimum time. So second one is also very simple, exactly same. So you complete it. Now we consider limit using L'Hospital rule. But here we have to use Leibniz rule of differentiation. You know, differentiation under integral sign. So I have already discussed it in definite integration, differentiation under Leibniz rule. So what is the rule? If fx equals to a to psi x ft dt, this is function of, so suppose this is ht dt, it is function of t. If we integrate it, so upper limit is phi x, so that is why it is function of x. So if we differentiate it, we get f dash x equals to integration omitted h of psi x, t is replaced by psi x, then derivative of the numerator, that is psi dash x with respect to x, minus t is replaced by lower limit and derivative of lower limit. So if it is constant, so it is derivative of constant is 0. So we get this one. So this is Leibniz rule. So I have already discussed it in details. So we need here simple application where denominator is constant. Denominator is constant. So what is the rule? You look again. If we differentiate it, so integration, this is omitted and t is replaced by upper limit, then derivative of upper limit. So there is second part also. If it is suppose phi x to psi x, then f dash x is h into phi dash, h into phi x into phi dash x minus h into psi x. This one is general into phi dash x minus h, t is replaced by lower limit, derivative of lower limit. but its lower limit is constant, no need of this part. So this is our working tool. You may consult my earlier videos regarding Leibniz rule of differentiation under integral sign. So problem number 10. So x tends to 0. So 0 to 0, upper limit, lower limit same. So numerator is 0, denominator is 0. So limit x tends to 0 by L'Hospital rule. So cos of x to the power 4, t is replaced by x square. So x to the power 4 into derivative of x square 2x. Lower limit is 0, so no need. Then OW, x into cos x plus sin x plus sin x. Now it reduces to problem of limit. So divide throughout by x. So 2 cos x to the power 4. So this is cos x. This is sin x by x. Dividing by x. X cancel. Now cos 0 is 1. 2 into cos 0. So this is cos 0. This is 1. So 2 by 2. This is 1. So what is value of the limit? Value of the limit is 1. So L'Hospital rule with the help of Leibniz rule of differentiation. Now problem number, suppose 12. Problem number 12. 16 same that of 10. So we consider problem number 12. So problem number 12. This is limit x tends to 0. This is x. Y to a e to the power sin square t plus a to x plus y e to the power sin square t total dt. So look, we change the limit, that is why a to this. Now from property of definite integration, so this same. So this is y to x plus y e to the power sin square t dt. So simplifying, we get this one. Now look, denominator, if we put x equals to 0, this is 0. And numerator x0, so this is y to y, upper limit, lower limit same. So this is 0 by 0 form. Now use Newton's Leibniz rule to the numerator. Differentiating with respect to x. So e to the power sin square x plus y. Then derivative of x plus y with respect to x, considering y as constant. So 1 plus 0. Lower limit is y, this is constant. And this is 1. So put y equals to 0. So e to the power sin square x. Answer is e to the power sin square x. So L'Hospital rule and Newton's Leibniz rule of differentiation under integral sign. Then problem number 5. So problem number 5. So look, this is x cube, this one is 0 to x, t by t to the power 4 plus 4. So if x equals to 0, then upper limit, lower limit 0, this is 0 by 0 form. This is 0 by 0 form. So limit x tends to 0. This is 3x square. And this one is t is replaced by x into 1 plus x by t to the power 4, x to the power 4 plus x. Derivative of upper limit is 1. Now 1x is cancelled out. Limit x tends to 0, 1 plus x. So 3x into 1 plus x. 1 plus x. 3x into x to the power 4 plus 4. So x into 1 plus x, 1 plus x, 3x square. So 1x is cancelled, 3x. So x tends to 0. X tends to 0. So look it again, 0 to x, this. So this is log 1 plus t. This one is, look, major mistake. So this will be log 1 plus x. Log 1 plus t dt. Then second step is x. This one is not x. Log 1 plus x. So t is replaced by x. Then derivative of upper limit is 1. So this is log. So log 1 plus x. 3x into x to the power 4 plus 4. Now listen again. If you put x equals to 0, this is again 0 by 0 form. Again 0 by 0 form. So differentiate it again with respect to x. 1 by 1 plus x. So by product rule, 3 into x to the power 4 plus 4. Then 3x unchanged. This is 4x cubed. So finally, limit x tends to 0. So 1 by 3 into 1 plus x. 3 into 1 plus x to the power 4 plus 4, x to the power 4 plus 4, plus 4 x to the power 4, x to the power 4 plus 4 plus 4 x to the power 4. Now put x equals to 0. So this is 3, 1 plus 0. So this is 0 plus 4 plus 0. So 1 by 12. Answer is 1 by 12. So look, if you do not use Leibniz rule, then we have to integrate it, then find values. So for this type of problem, we always use differentiation under integral sign by Leibniz rule. So this is problem of IIT. Now not difficult. Now we consider problem number 15. The graph y equals to fx has unit tangent at a0 through which graph passes. The limit x tends to 0. X tends to a log 1 plus fx by 3fa. So at a0, unit tangent, at a0, it has unit tangent at a0. That is, it passes through a0. So the graph fx passes through a0, passes through a0. Therefore, fa equals to 0. We are getting fa equals to 0. Now limit x tends to a. So fa is 0, so denominator is 0. So this is also fa log 1 0 by 0 form. So differentiate. So if it is 0 by 0 form, so we can use L'Hospital rule. So using L'Hospital rule, 1 by 1 plus, this is 6fx. 6fx into 6f dash x by 3f dash x. Now it has unit tangent. Unit tangent. So f dash x is cancelled out. So what we are getting? 6 by 3 into 1 plus 6fx. So if we put x equals to a 6 by 3, 1 plus 6fa. Now fa is 0. So value is 2. Unit tangent. So f dash a exists and finite. So through this video today we have discussed how to find limit using L'Hospital rule for typical problem, that is when we have to use differentiation under Leibniz rule also. So these problems are most important for competitive exam. You solve rest of the problem. Thank you.